Okay, I hope you're all having a great day today. We're going to start by going over the 9 problems I told you to do as practice. So here are the answers to those. And if you didn't do it, then that's just not going to help you out in the long run, because you have to practice to become good at something. And it's called integrity, doing the right thing when nobody's looking, right? So let's take a look at this one. All of the numbers that are less than -2, not equal to, so it's an open circle going to the left. All of the numbers that are greater than or equal to, so that's going to be a closed circle going to the right. V is less than or equal to, so closed circle. Less than or equal to all of the numbers that are less than -13, less are always to the left. Less to the left. All of the numbers greater than 4 start at 4. It's not including it, so it's an open circle. And if you have your variable on the left, this is pointing in the direction, but it's all the numbers larger. All the numbers larger than 4. For this one right here, when you look at this, your variable is not on the left. It's easy just to switch it around, and that's what I would do. When you switch it around, don't forget, the alligator's got to be eating that K. So K greater than or less than 7, and because it's equal to, I'm coloring that in. All the numbers greater, so it's going to the right. Let's take a look at this one. Again, my variable is on the right. I want to switch that up. The alligator's got to be eating the -20. So R less than, or not, R less than -20. No equal sign, so it's open and it's going to the right. All the numbers smaller than -20. I had you do number 9, 7, or 1 through 9. So let's take a look here. It says a number is greater than -7. So X stands for some number. A number is greater than -7. Open circle going to the right at -7. A number is less than or equal to 1. X is less than or equal to 1. Closed circle at 1. All the numbers smaller, so I'm going to the left. Let's take a look at this, the last one. A number is at most, and that was right off the example we had with our notes. So X less than or equal to 12, so it's a closed circle going in this direction. Now you might be saying, oh no, I did it wrong because Mrs. Merz's are all above there. I'm showing you that because it's an easier way to see it on the video. It could have looked like this. Doesn't matter. Doesn't matter how you did it. You're just showing that you know where the set is. Maybe you didn't do that squiggly line. Maybe you did yours like this, just a little bit darker. Either way, pay attention to the closed circle, open circle, and what direction you're going in. So let's go back to our notes. And we ended on Thursday with, whoopsie, this page of the notes. So now we're going to go over to the second page of the notes. All right, drop my pen. There it is. So you're going to have some examples like this on the work that you're going to be turning in today. So let's take a look at these. Let's take a look at those. So we just have to substitute in the value and see if it's true. If it's true, we write yes. If it's not true, we write no. So we got to substitute in. So this is saying take this number right here, because it says state whether the number is a solution for the given inequality. So I'm going to substitute that in for my X. You can rewrite it. -16 is greater than -9. I don't think that's true. -16 is a smaller number, so that's a no. Nope. So I'm going to substitute in that for M. 12 is greater or equal to 12. Oh, sure. 12 equals 12 every single day. Let's take a look at this one. The -2 is going to be substituted in for the Y. So -2 is less than -2.5. Well, if you're not sure, draw yourself a number line. I know that this would be 0, -1, -2, -3. Well, this is -2 right there. And -2.5, well, that's going to be somewhere around here, right? -2.5. This is -2.5. And it says here that -2 is less than -2.5. Well, that's not true. That's not true. -2.5 is a smaller number than -2, so that's a no. That was a little bit trickier. Let's take a look here. Substitute in that value. Is 4.2 less than 4.2? No. They're equal to each other. No. Let's take a look. Well, these right here, when I'm comparing fractions, I can't tell. If I have a pizza cut into 8 pieces and I eat 7 of them, am I getting more pizza here or here if I have a pizza cut into 6 slices and I eat 5 of those? Geez, I don't know. Well, the easiest way to compare fractions is to use our calculator and take those fractions and turn them into decimals. So, you could do it one of 2 ways. I could just say 7 divided by 8, or I could use my N over D button. Let's use the N over D button. 7/8, enter, it gives me 7/8 back, double arrow button. So 7/8 is 0.875. And then whatever this is, I'm going to substitute in for the V, so I'm going to put it in front of it. So let's take a look at this one. N over D button, 5/6. Enter, gives me 5/6 back. Double arrow, that's 0.83 repeating. 0.8 with the 3 repeating. So let's take a look at that. This is, if I was thinking about money, this is 83 cents. And this is 87.5 cents, right? 8.75. 0.875. Well, is 83 cents less than or equal to 87 cents? Yes, it is. So, but just looking at these fractions before changing them into decimals, I didn't have any idea. So let's take a look at this one. This is a mixed number, 2 2/3, and this is an improper fraction. Geez, I don't know. Well, this 2 2/3, I have a pretty good, I know what that is. It's 2 and then almost, with another third, it would have been 3, but it's less than 3. Let's see what 13/4 is. 13/4, enter, double arrow. Oh, well, 3.25. And I know that 3 is bigger than 2 always, right? So I could change that into a decimal and make this 2.6, but no, I'm not going to. Let's say this is yes. Yes, 3.25 is greater than or equal to 2 2/3. That's a yes. So let's move on to the rest of our notes now. So this is the note packet that we're working on. I just did these examples, and you're going to have ones like that on your homework today. Let's take a look at solving inequalities. Solving inequalities, you follow the same steps for solving equations, but stop if you multiply, multiply, or divide, divide. So if you multiply or divide by a negative, negative number, then you must flip FLIP. Oh, let me rewrite that because that's kind of messy, and I want it to be nice and neat for you. FLIP. Stop. If you multiply or divide by a negative number, you must flip the inequality symbol. So, only when I'm multiplying or dividing, It didn't say anything about adding or subtracting, and only when it's a negative number. So if I'm multiplying or dividing by a positive number, this rule doesn't happen. Only when I'm multiplying or dividing by a negative number do I flip. So here's an example of flip. X greater than 7. If I flip that, it would be x less than 7. So that's what they mean by flip. But only when you're multiplying or dividing by a negative number. So just like we solved equations, we're going to solve inequalities in one-step, two-step, multi-step, but we're probably only going to get to two-step inequalities. Let's take a look at this. It says here, p minus 2 is less than or equal to negative 11. I need to get that p all by itself. I need to get that variable by itself so I can solve the inequality and then graph it. So just like we did before, you can use this. This sign represents the inequality symbol now. So I want to get rid of this negative 2. The opposite of minusing 2 is to add 2 to both sides. Very good. That makes that become 0. And anything plus 0 is that thing. So I have p all by itself. Now I did not multiply or divide by a negative number, so this inequality stays the same. It does not flip. Here I have 11 negatives and 2 positives, so I know I have more negatives. How many more of them? 9. If you didn't know that, put it in your calculator. Now they want me to graph it. So in order to graph this, I'm going to put my negative 9 right here in the middle. And I don't really have to put any other numbers here. I will today, negative 9. So I know that this would be negative 8, negative 7, negative 6, and this would be negative 10, negative 11, negative 12. Let's take a look. Negative 9 is going to have a closed circle because I see that I also have the equal sign. So I'm going to put a closed circle at negative 9. And all the numbers that are less than or equal to negative 9 means I'm going in this direction. Now, if it's easier for you maybe to use a different color or a highlighter or something like that, that'd be great. So if you just think this is harder to do or sloppy or whatever, you could just use that, just saying it's going in this direction. We just need it to show, the graph on the number line needs to show the direction that we're going in. So I'm drawing my line, I'm taking a look at this, and I'm thinking, I don't like the way this is laid out. These are all too close. So what I'm going to do is rewrite it. K divided by 7 is less than 2. Now I have way more room. All right, I want to do the opposite here of, this says K divided by 7. The opposite of dividing by 7 is to multiply both sides by 7. Now here, am I multiplying or dividing by a negative number? No. Nothing's going to change with the direction of my inequality. 7 divided by 7 is 1, and 1 times k is k. I have my variable by itself. I don't change the direction of the inequality, and 2 times 7 is 14. I need 14 on my number line. It's really all I need on my number line. That's going to be an open circle. All the numbers less than 14 go in this direction. That's all I need. If you want to fill out your whole number line, go ahead. But you don't need to. Let's take a look at number 19. Number 19. I got plenty of room here. So I am going to do the opposite of subtracting 20, which means to add 20 to both sides. And when I do that, this becomes 0, because negative 20 plus 20 is 0. Anything plus 0 is that thing. That's the identity property of addition. And if here I know my answer is going to be negative because I have more negatives. So negative 15. Man, I don't like having my variable on the right. I'm going to switch it up. A, the alligator has to be eating the A. Negative 15. I did not multiply or divide by a negative number there. So nothing, I'm flipping my inequality, but really I'm just rewriting it with the variable on the left. So I did not flip it. I did not change its value at this point. So now I'm just going to put negative 15 on here. And to show me the direction, I know this is 0 and maybe this is -20, just for my direction so I know which way I'm going. But I do know what way I'm going here. I'm going to have a closed circle at -15, and because my variable is on the left, that's going to point in the direction I need to go in. This is saying all the numbers greater than or equal to -15. And that's what that says right there. So let's take a look. I'm going to stop here because this one is going to change it. It's going to be, we're going to change the direction. But I just want to stop there for today. We'll start here again on Tuesday. So I want you to get back to your practice sheet, because on the practice sheet, if you look at the bottom here, everybody got that? You have your practice. We did 1 through 9 already. Now we're going to come over here and you're going to do 13 through 17. So this is going to give you 3 examples similar to this here. And it's going to give you 2 solving the inequalities without doing any flipping, right? For this one, I got to get rid of this -5. I got to get it to the other side. And this one, I'm going to be dividing, but it's by a positive number. So for today, you're doing problems 13 through 17. And that's it. I hope you guys all have a great day, and I will talk to you on Tuesday.